Hello everybody. Thank you for selecting this video. I hope you will enjoy the subject that I have presented to you today.
Okay, I'm dealing today with global streams that are part typical of a table or a class, an object that holds very long streams of data, much longer than any string. And therefore it has a special structure to be stored. There is no problem with the streams as long as you use them inside the table to display them. But sometimes you run into situations where the environment around the stream is lost. And then it's a very hard job to find out what is the content, is it valid? Or if you have to get into a particular piece of the stream, it's not really easy anymore. There is no problem to watch and examine a global using command line, using the system management portal or any other global viewer, but you never get the whole thing as it's typically very large. And on top of it, we see 4 different types of contents. And only the containing class know what the content is. And these 4 types can be a character stream, which is a flat sequence of characters, a binary stream. It means you just have bytes with no special representation, and both of them can also be compressed, which means their content is condensed by using zip, which makes it totally unreadable. So you have in that situation no chance to find out what the content is. My small tool will allow you to look into the streams, decompress it if they are compressed, and especially to find out what is the content. Is it binary? Is it a text? Is it compressed text? This is something that you cannot do using the management portal or the SQL shell, as both of them do not extract the content but just hand you over the OID of the stream, and then you are left alone. Of course, you want to have a tool, and this was the purpose to writing it, to map the used stream global that is different for every class, different for every table that you create, for all them together. So you need a dynamic mapping on the stream global to see the content. And using SQL, there are very nice tools like WinSQL that I will use to present you what is the content of these streams. For this demonstration, I have installed already an instance of Docker and have a container running. It is starting, and now as a first step we log into this container. Okay, we are in the namespace user. We take a look at the provided test data. And you see we have for some JPEG data, MP3, a PDF, and we have a text prepared, another JPEG. And in order to make this working, we load this into various stream clovers. This is just for the presentation now. Normally your streams are already somewhere created by your class, by your table, and you just have to find out the name of the stream clover. In this case, as we don't have any classes prepared and no data, this is a little bit artificial, but in principle it's the same as if the data were generated by some application. And now we are going to load this data. There's a small loader provided for Docker, and you see we have created 3 stream clovers, 1 text, four. Text clover, text stream for JPEG streams, for MP3 streams, and for a PDF stream. This is not necessarily required to separate them. It's just for the demo to easier find the contents and to hold them apart. It's just a little bit of comfort here. And you should keep in mind those names, since we will use them later on when we access this stream clovers with the utility over SQL. So I have now changed to my WinSQL. I decided to use WinSQL because of the easier presentation of the results. I've also tried Squirrel or DBweaver. It's all they work fine. You have to establish your ODBC or GDBC connection, and then it's just another table, and the table is named rc.gstream, global stream, and you see here the properties, binary, body. Body is the content of the first piece of the stream, and it's presented as a string, as a varchar, so we can apply string operation for searching data. Then you have the zipped version of the binary. You have the character presentation, that's the more or less default. You have the zipped character presentation, and of course you have an ID, and you have the number of chunks used inside the clovers. This means the sublevels where all these pieces are stored, and finally the total size. That's how this class is set up. And now we are going to take a look into our first clover. So first, an explanation of the query itself. I select all fields, so all type of possible streams, and the where clause uses a stored procedure that does the init, that does prepare the access and the mapping to the stream clover we use. And we see, and if the clover doesn't exist, the reply is 0, so it doesn't run. So it is some kind of security here behind, and we see this our 4 stream clovers that we're going to watch, and I will use this queries always with condition 1, and as this is not related to any row information, this procedure is executed before anything else, so it's the real best place for init of a virtual table. Okay, let's do it. We execute it, and we see our first results. We see a body, and if we want to see it a little bit larger, I have a zoom option. So this is the content that I see. This is the binary where the real text is visible in the body. With the zoom option, it's just a sequence of numbers, and therefore the binary representation is, you see just the hex values presented here. So what do we see else? The characters, again, the zipped characters, you do not see it in the zipped format, but it's already unzipped here. So zip is just handled at the side of iris, and you have, it's just a storage option. It doesn't affect in any way the representation over SQL. So then, as a next, I have stored this as zipped explicitly, which means the body is just a chunk. It's not readable. You can forget it. This unzipped version, of course, is now the content we had expected before. The different you see here makes it interesting. So, and then we have some much longer tests, also again the binary, which is not of interest at the moment, since we don't have any binary stuff. We just have characters, and it tells us it's long, it's very long. So okay, let's see what it is. It's this lorem ipsum stuff, which just roll it through. It has a length of more than 4,000 characters, so it's not real a thrill for Iris, but a thrill for SQL. And then in the character, that's a real funny thing. That's the zipped version. You see it unzipped. Oops. Oh, I was in the wrong order. So now you see it unzipped, and this is just some Chinese looking stuff. It's zipped characters here. So far on the zipped variant with short text, with a longer text, nothing dramatic. So for our next, I'm going for the PDF. And execute it. You see, preparation takes a little bit of time, and we have the clear text version. clear text version as characters. Let's go in here, zoom it, and you see a PDF formatter. Yeah, that ends with a stream of something, as PDFs used to do. The character zip is not really interesting in this case. More interesting is the binary value, which is the real zip. And now we have the option to say, okay, I want to see this as PDF. And we have here our PDF document. It was the announcement of this test that I have printed into a PDF. I close this. I close this as well. And now I go for the zipped version, which is significantly smaller. And also here I get the unzipped value. So if I go for the PDF, we see exactly the same image. So for the presentation in SQL, there is just no difference whether it's zipped or not zipped. The zipped functionality is just a piece inside Iris. It does not affect SQL, and that's quite important to us to understand. So in fact, for the outside world, there's just either binary or character and nothing else between. The fact that it is zipped during storage doesn't bother the SQL world. It's something that happens inside the Iris environment. Okay, in the next step, I go for the JPEG. And execute my query. That is running. It has to do something. Yeah, my Docker is not the fastest. Oops. And I see this is not working. It's not working because I missed here. I had a typo in the global name. The global didn't exist, so nothing happened, no result. I change it. You see it's syncing, and okay, we are here back again, and well, we do not care about characters or anything else. It's either unreadable or just too long to be displayed. Of course, we're dealing with JPEGs, so there is no need to have character view. You see the text and you go for image, and the image is the one from our invitation. No big surprise. So this is now from the zipped version. It doesn't like this, of course, since this is the zipped stuff. But we have the bzip, and now the image works. So we have to decide, how do we get this image? Just as a character would not work. As binary, it works. So we do the next. Well, You see, you know this guy, yeah. It's great to have him here in our presentation as well. And well, the next one, you see the length is significant now. It's 250,000 bytes. Well, this is a little bit of larger image, and you see, I'm also in here, yeah, just to have fun. Okay, and now let's go to our last. I skipped this zipped part as it's now getting boring here. If you do it with zip, it's just the same. Like here, zipped image, yeah, this is Terry again, so nothing drilling. Now we go to our MP3. Execute it. And well, see again about the difference. A very short body in the zipped version. Now I'll take the path over the zipped. It's of course no image, yeah, no big surprise, but it's something else. It's an MP3. So let's see. Okay, I think this is enough. You have seen also MP3 is working. Well, and now it's up to you to make use of this facility to investigate global streams in various ways using SQL.
Okay. This was the video. I hope you enjoyed it. I hope it was interesting to you. And I hope you will see me again with my next video on this channel. Goodbye.